We can't imagine the material that our beverage carton is made and the realities that are behind it. I'm Fernanda del Toro, and as industrial designer, I have been working on the potential transformation of a common post material, well known as Tetra Pak. Rethinking on the reuse of an enormous amount of a viable beverage carton that exists in the landfill was the starting point to this project. Massiveness post-material means a lot of beverage cartons thrown away worldwide. It's estimated that 1 ton is equal to 11,500 pieces of polyaluminium. Polyaluminium means polyethylene and aluminum foil that are inside the packaging. And 150 tons mean 468,750,000 pieces recycled in less than 1 year in the country. The technology of recycled packaging is there since 19th. Being a material with a lot of properties, but just a few plants haven't found profitable, and they have quit. So how to close the circular economy of the beverage carton? Smart enough to be efficient. The project explored many mixtures of the multi-layer packaging in different formats, with different processes in order to gain information about the futures of the samples and obtain the best of the post material. Through the transformation of a multi-layer material, we are closing an economy and making a collective commitment to create positive values, tradition, lifestyle, culture, and shown an easy way of doing it, with the effort to avoid expensive and complex processes or systems. During the experiment, sandwich layer by hot press, volumetric composite, cold extrusion by beverage carton, flat composite by hot press, and thermoform composite took place on the experiment section. Starting with making samples with different thickness and with bigger flakes in a more compact way to improve the thermal insulating property. This exploration was further to find some interesting insights. First, the grain is better in big size to make the stronger structure. Second, once the material is heating in the hot press, it can adapt to any kind of simple shape. Third, the material obtained can be stiff and flexible depending on the number of flakes. The process is quite simple that anyone can apply in their own workshop. 2 coatings were tested in the surface of the flat samples. One made of paper craft, another using a very thin polyethylene to match with the same kind of polymer of the material, helping to the material sample to avoid contamination and to avoid the drop of particles. The technology is as simple as effective. Empty beverage cartons are thrown into a hydropulper while water is added. No chemicals are used. The rotating action and water separate the fiber from the polyethylene and the aluminum. Then the material gets dry to the grinding process. On the grinding process, the oil heats the vat, and thus they heat the material after giving it shape. In the process of the board, the polyethylene melts and acts like a glue to attach the material, so there is not necessary any extra chemical glue. To understand the relevant properties was necessary some testings, such as impact resistance, tension testing, wear resistance, environmental resistance, and thermal insulation. Flake can achieve a high standard of toughness depending on the thickness. Flexural testing is a property that is still reaching through this material to define how flexible it can be without lose its shape or break it out. It's thermal sensitive, being as a potential material to quit simple thermoform. Against the external environment, a coat on the surface of the material should be significant for the development. It can reflect, but on exterior, the reflection will decrease during the time. It is lightweight and can be renewable. Flake is being a disposal material with a plus of CO2 reduction emissions because avoid the transformation process to get the raw material, and it can be renewable. The project is still working on a life cycle analysis to prove the safe in finite resources. Knowing that the polyaluminium has a thermal insulation property, it was found interesting to propose it as a cooler thermal bag or box to keep the inside fresh. The ability to float of the material because its lower density than the salt and the sweet water brought to the study the idea to develop a floating objects as a buoy to limit spaces in water. But as the abrasive effect through the water, the idea was harmful to nature. Due this, its release of the microplastic in the water. So this idea was discarded. A wind toy, in this case, shows the materiality of the beverage carton through a dynamic object by communicating the lightweight, versatility, reflection of the natural or artificial light, and the resistance to the environment. The final proposal is a light, versatile, and reflective wind toy that communicates the abundance of a non-recycled material worldwide. Proposing circular production, thinking in modular pieces, and easy to cut and attach together. Artists and designers can take advantage of the material to experiment with through a communication of the massive disposal that the material represents. It would be a great idea to keep in touch students of design, environmental, and engineering to give them a look about the massive post-material that they have available, raising a new value of beverage carton into society, a material that can be outside to follow the wind. Material that keeps it warm. A material that keeps it cold. A material that follows the wind.